Hello viewers, welcome back to my second tutorial on first order linear differential equation. So in this video we have this problem: x squared y prime plus xy equals 1. We solved in our previous video a different first order differential equation, but this one, it includes a condition which we call the initial condition: y of 1 is equal to 2. So let's see how we go by this. Kindly follow this video to the end and don't forget to subscribe. So to go about by this, we have to make sure that the coefficient of y prime is 1. That is a condition in first order linear differential equation. So we have to make sure that the coefficient of this y prime becomes 1. So we divide through by its coefficient, which is x squared. We are going to have y prime plus, here we are going to get x y over s squared. Here let me add the s squared to make things simpler. Over s squared is equal to 1 over s squared. So here it will cancel, so that you get y prime plus y over x is equal to 1 over s squared. The next thing to do is to find the integrating factor. So integrating factor, which is always giving us mu of t, which is equal to e to the power integral of p of t, where p of t is the coefficient of the y. So in our problem, we have the coefficient of y to be 1 over x. So we have the integrating factor mu of t to be equal to e to the power integral of 1 over x. You know that integral of 1 over x is ln x, so this will be equal to e to the power ln x. Now, e to the power ln x, there is a e which you don't write here, which is a log to the base e. So the answer becomes x from logarithm. So if you have e to the power ln, the answer becomes the number of the ln, that is x. So this is our integrating factor x. The next thing to do is to multiply the integrating factor by every term in the equation. So you are going to have, the next thing is you're going to have s squared. So here, when you simplify the equation, we are left with y prime plus y over x is equal to this. So from here, we're going to continue from that place. We have y prime multiplied by x plus x multiplied by 1 over x is equal to 1 over x squared multiplied by x. From the condition of first order linear differential equation, this times this will always give us the derivative of this x, that is the derivative of the integrating factor, which is a condition. So this whole equation is always represented by the product of y and the integrating factor x, all to the power prime. That is the derivative of the entire product of y and the integrating factor, which is x here, is equal to, this will cancel this and be left with 1 over x. At this point, we have to find y, so we have to take integral on both sides, and that will give us, integral will cancel this derivative and be left with y multiplied by x plus c is equal to, integral of this will give us ln x plus c. Now in differential equation, the c will not go to cancel it, but will rather add up to it. So you get y multiplied by x is equal to ln of x plus c. It becomes the same and to not affect the answer. So at this point, to make y the subject, to divide through by x, then by x. So our answer will become y is equal to ln x over x plus c over x. So this becomes the solution for the first order linear differential equation. But from the initial condition, y of 1 is equal to 2, and it said s is greater than 0. S is greater than 0 because if s is 0, it becomes undefined. So we have to apply the initial condition to get a value of c. So we have the initial condition, y of 1 is equal to 2. Wherever we see y, we put 2, and x, we put 1. We are going to have 2 is equal to ln of 1 over 1 plus c on 1. Ln of 1 or log of 1 is always 0, so this will become 0. So we get 2 is equal to c. So c is 2. So our final answer for the differential equation becomes y is equal to ln of x over x plus 2 on x, and this is the final answer. Thanks for watching. Kindly subscribe so that you get notice of subsequent videos I'm going to post. Thank you.